So today we're going over chapter 7, section 3, proving that a quadrilateral is a parallelogram. Now, just so you guys know, this is basically the converse of lesson 2. So I'm going to write that up here just so you guys have an idea. The converse of lesson 7.2. That means that for the theorem, the if and then are flipped. So if you guys are understood 7.2, you should be fine for 7.3. So let's start with theorem 7.7, parallelograms, opposite sides, converse. Now, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Remember, this was the first way to prove that quadrilateral is a quadrilateral. They gave us that the two lines had to be parallel. So because they're parallel and it's a parallelogram, it would be congruent. So I'm going to write in here, remember that's the first way. I'm going to refer to lesson 7.2 as much as I can so you guys have an idea of what's going on. So to prove the quadrilateral is a parallelogram. So I'm going to do the shape because I'm running out of space. Now, key word right here, both pairs need to be congruent and opposite of each other. So again, these two have to be congruent and those two have to be congruent. It's always the opposites. So if they tell us if segment AB is congruent to segment CD and they give us segment BC is congruent to segment DA, then we know the quadrilateral ABCD is a parallelogram. So we're working backwards. Before they told us it was a parallelogram, so we were able to say the segments are congruent, the opposite segments. Now they gave us a segment, so we were able to say that it is a parallelogram. Now for theorem 7.8, we have parallelogram, opposite angles, converse. Again, this was the second way to prove the quad is a parallelogram. And again, if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So I'm going to write what I said about the second way. This is the second way to prove the quadrilateral is a parallelogram. Now again, keyword both pairs. So in this case, it would be angle B with angle D and angle A with angle C. Again, opposite, just like we learned in 7.2. So if they tell us that if angle A is congruent to angle C, and they also tell us that angle B is congruent to angle D, then we can say that this quadrilateral ABCD is a parallelogram. We can say it because they gave us the congruent angles. Before they would tell us it's a parallelogram, and we learned that the angles opposite of each other were congruent. In this case, they gave us the angles that are congruent, but they don't tell us it's a parallelogram. So these are the converse. This worked from angle to side, when the other one we were working from the shape to the angle, or the side to the angle. So here we have theorem 7.9, which is opposite sides parallel and congruent theorem. This will be the third way to prove the quadrilateral is a parallelogram. Now, what does this state? This states that if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. The keywords are congruent, parallel, and the word and. Keep in mind, this is for one pair. So they have to be congruent and they have to be parallel. If they are not parallel and they are not congruent, and it has to be the same side, then this is not a parallelogram. You can't prove it based on this theorem. So just to reiterate it, same pair, like I just said. Same pair of sides has to be both. Again, both parallel and congruent. If it's not that, it cannot be a parallelogram. So if you have for example, something like this, they tell you the top ones are parallel, the side ones are congruent, this cannot, so can't be a parallelogram. But if they tell you, this is the no, the yellow side. I'm going to change the color for the yes. If they tell you, if segment BC is parallel to segment AD, which is what's shown in the diagram, and they tell us also that BC is congruent to AD, then because it's the same pair, we can say that ABCD is a parallelogram. So again, the key right there is has to be the same segment. So now we have theorem 7.10, which is parallelogram diagonals converse. Again, this is the fourth way to prove it. I'm just keeping track. So you know how many ways you have to study for your quiz. Now keep in mind that if you know from 7.2 all the properties of the parallelogram, you should be able to work backwards for all of this section. So this is just so you guys know how many converses we have from 7.2. So if the diagonal of the quadrilateral bisects each other, then the quadrilateral is a parallelogram. Again, let's name this point E just for convenience purposes. They tell us that the segments bisect. We know that it's a property from a parallelogram because we learned it in 7.2. So if they tell you if segment BD and segment AC bisect each other, then we know that ABCD is a parallelogram. They can also tell you that BE is congruent to ED and AE is congruent to EC. And if they tell you that, then we can say that ABCD is a parallelogram. Okay, so here we have 5 ways to prove a quadrilateral is a parallelogram. Now, this basically sums up all of the slides we've seen previous to this one, so the first 5 slides. So I'm going to write that in. This sums it all up as of right now. The 5 ways. Now, we got to know or realize that this is each theorem individually, but it's not the actual name of the theorem. So when you're studying for your quiz and your test, you can look at this to remember and study the properties, but please do also try to remember the names. So we can use the 4 properties and definitions to show that the quadrilateral is a parallelogram. Now, I'm not going to read all 5 points. Please take a second and do that yourself. Again, this is just what the 5 slides we have gone over. So those are the properties, the parallel lines, the opposite angles, the same pair of congruent sides that are also congruent, the opposite angles that are congruent, the opposite sides that are congruent, and the diagonals that bisect. I don't think I said them. I said them all. I just don't know if I repeated myself. So please do take a second to read them yourselves. So guys, this slide is the same as the previous slide with pictures, so I'm just going to write that. Just with pictures. This is great. I'm a very visual learner, so this would be a lot better for me to learn. And it tells me the theorems as you read them, which is great. So we have the 4 theorems and the definition. So for me, it's easier to see it. If you guys are not a visual learner, that's fine. For me, it's a lot easier to just study this. So this is example 1. It wants us to state the principal definition or theorem that enables you to deduce from the given information that the quadrilateral is a parallelogram. Alright, so first of all, before we start to answer these, I want to say that please do not use the theorem number. I don't memorize theorem numbers. I don't think anybody does. Either use the theorem name or just restate the theorem or definition. If you do that, I'm able to tell where you guys are coming from, what you're trying to say, as I don't know them all. So if you guys don't remember the name, let's say of the first one. So if they're telling us that BE, this one, and ED are congruent, and CE and EA are congruent, oh, they miss a little segment lines and the little squiggly. Are congruent, we know that's going to be the diagonal, the diagonal bisects each other are congruent. If you don't know the name, which is the diagonals converse, so parallelogram diagonal converse, because I know you guys aren't robots, and honestly, I don't know half of the names either. I read them and I remember. I know how they work though, and that's enough information. So if you forget the name, you're welcome to write if diagonals of a quadrilateral bisect each other, then parallelogram. I'm okay with that. If you for some reason forget the theorem name, I know it's going to be a lot more writing, but you still are able to get points because I understand that you get what's going on here. Now, for the second one, they're telling us that angle BAD, so this whole one right here, equals angle DCB, which is this one right here, and angle ADC, this one right here, equals angle CBA. Again, they forgot the little congruent sign, but it's okay. So we can say that, I'm going to write both ways, the long one for the definition and the name of the theorem or the converse. So if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Now, if you remember the name, that's even better. The name for this one is parallelogram opposite angle converse. So I'm going to highlight the name of this one right here just because it blends in. Same with the other one. This is the name. Now for the first one, they're telling us BC is congruent to AD. And they're also telling us AB is congruent to DC. Again, this should be the little segment lines right here. They're not, but that's okay. Oh wow, sorry, I skipped 3, guys. I'm gonna go to 4 and then we'll do 3. Alright, so for 4, I skipped 3, we'll come back to it. We have if both pairs of angles, pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Now, the name for that is the parallelogram opposite side converse. I'm going to highlight it as well so you guys have the title right there. Now, for number 3, I'm sorry I missed it. They're telling us segment BC is parallel to AD. and they're telling us AB is parallel to CD. Now that is a definition, that is not a theorem, so we just have to put definition of a parallelogram. And then for the last one, we have that BC is parallel to AD, and it's also telling us the segment BC is congruent to AD. So this is the opposite side parallel congruence theorem. I'm going to write it on the side right here for 5. Opposite side parallel and congruent theorem. That's the title. And that says, I'm just going to try to fit it. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. I'm going to highlight, guys, that number 5, that this is the title right here, the name. Everything else is on the side right there. I just ran out of space. All right, let's go over example 2. They're saying, for what value of x and y is the quadrilateral PQRS a parallelogram? And since they want us to solve for x and y, we know that these two are going to be congruent, and these two are going to be congruent. Now that is based on the parallelogram opposite side converse, that if both pairs opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. So in order to find x, we gotta say that PQ is congruent to SR, which I just marked, and we gotta say that PS is congruent to QR. So since QR has an x and it's also y, we have to solve for x first. That's the only way to be able to solve this, or the easiest way. It's not the only. So we can set up x plus 9 equals 2x minus 1. I'm going to move the x over. So I'm going to get 9 is equal to x minus 1. I'm going to add the 1, and I get that 10 is equal to x. Awesome. We solved the first part of the question. Now, before I move on, you guys can check it. We can plug x into here and here. If we do, we're going to get 10 plus 9 for segment PQ. So that's going to give us 19. And for segment SR, we're going to plug in 2 times 10 minus 1. So that's going to be 20 minus 1. Gives us 19. It is a way of checking, guys. Since it is the same for both when we checked, we know we did the math correctly. Now, in order to find y, we're going to do the same thing. We're going to know that PQ is congruent to SR. So we can say y is equal, PS is congruent to QR, which is y is equal to x plus 7. Now again, there's 2 different variables, so we can use the x that we found and plug it into that x. We're going to get y is equal to 10 plus 7. So we get that y is equal to 17. Again, you're welcome to check by plugging it in here and in here. Now we plug it into the y alone, we get the y, so PS is just y, which is just 17. Awesome. And RQ is x plus 7, and since x is 10, we can plug in 10 plus 7, which does give us 17. Therefore, proving it is also the same, so it is correct. The math that you did is correct. So we can say that x is equal to 10, and that y is equal to 17. And then that would be your final answer, because that is what they are asking. So for example 3, they're asking us again to solve for x and y to make sure that the quadrilateral ABCD is a parallelogram. Again, since we know in a parallelogram opposite angles are congruent, we can just equal them to each other. So I'm going to actually solve for x first, just because I feel like solving for x first. It's in the top left corner. So we can say angle A is congruent to angle C. So let's start. We do angle A, 3x minus 32. It's congruent to angle C, which is 2x. I set it up. I'm going to actually move the 2x over. So I'm going to get x minus 32 equals to 0. And then I'm going to move the 32 over, and I get x is equal to 32. Now again, you can plug it in and solve for it. We'll plug them in after we solve for x and y. So let's find y. For y, we have angle B is congruent to angle D. So we're going to get 4y is equal to y plus 87. I'm going to move the y over, and it's going to leave me with 3y is equal to 87. When I divide that by 3, I get that y is equal to 29. Now let's plug them in just to double check our work. When we plug in x, we're going to get, for angle A, it's going to be 3 times 32 minus 32. So we're going to be left with 96 minus 32, which is going to give us that angle A is equal to 64. When we plug 32 into angle C, it's going to be 2 times 32, which is going to give us 64. Again, they are the same, so we know the x works. Now, we do the same thing for y if we want to check it. So we're going to do for angle B, it's going to be 4 times 29, and that's going to give us 116. And for angle D, it's going to be 29 plus 87 is going to give us 116. Again, they both work, so we can say x is equal to 32 and y is equal to 29. All right, so let's do example 4. So write a 2-column proof. It's given that angle ADB is congruent to angle CBD, and angle ABD is congruent to angle CBD. So it's basically already drawn on the diagram, and they want us to prove that the quadrilateral ABCD is a parallelogram. In order for us to be able to prove that this is a parallelogram, we're going to have to state or figure out how to say that the lines are congruent. So I'm going to start by writing statement and reasons. Again, this is a very short proof. If you guys know the theorems and the converse, the proof should be fairly easy because you'll know how to move around in order to make it work. So again, I'm going to start with the given. So ADB is congruent to CBD, and angle ABD is congruent to angle CDB. Now, that is the given. That's always the first one. Now, as I was mentioning, if you guys remember the alternate interior angle theorems and the converse, you'll remember that there is an alternate interior angles converse. That's going to state that if they give you alternate interior angles are congruent, you can say that the two parallel lines and the transversal, this being the transversal right here, we can state that the other segments are parallel. So we would get that AB is parallel to CD, and we get that AD is parallel to BD. So let's write that in. So AB is parallel to CD, and AD is parallel to BC. Now, because I just mentioned the name, we're just going to write alternate interior angles. So alternate interior angles converse. And then for the third step, since we already were able to prove that the segments were parallel from the top and the bottom, we're able to say that ABCD is a parallelogram. Again, guys, remember what's stated in the proof is always the last statement. And we know this is the definition of a parallelogram. So because we know this is a definition of a parallelogram, just to remind you guys, the definition states if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram. Again, I cannot say this enough, guys. Make sure you know the theorems and the properties This is the only way to make sure that the proofs are easy. So reminder, you guys do have homework. It will be posted shortly.